Next is discharge between two streamline between two streamlines. Suppose this is a streamline another streamline, these two. Suppose fluid is flowing V and this is 1, this is dy. Taken a section, this is the velocity of V, this is y distance, and this one is dy. This is the dy. Now we know the discharge dq equal to dA into V. dA equal to, here dx at this section dx equal to 0, so dy into dA into y or dA, sorry, dA equal to dy into 1 into V, so dq equal to dy into V. This is the equation number 1. And another d not dx into dx delta x into dy. This value is 0, so 1. This value is u equal to d sigma minus d sigma into dy. So this value in v into dy. Here u equal to v, u equal to minus, we know, and this is the another equation, and so d phi minus d phi into vt, this is the equation 2. So comparing both of them and we get dq equal to minus d del sorry, this is the value. So integrating both sides, q equal to sigma 1 minus psi 1 into psi 2 minus psi 2. This is integration both of them, then get this value. So this is the very important for IS exam. Now we know this is the stream function. We know d phi in by dx and dy in minus d phi into dy, and now phi equal to 2xy minus x, d phi into dx minus 2y plus 1. d5 into dy minus 2x. Okay, now we know u equal to minus d psi by dy. So u value is from into 1 minus psi into dy. This is the one equation, and 2y minus y equal to d psi delta psi into d, and this value is here, and integrating both of them, y square by 2 minus y equal to sigma plus c. 2 cancel out, so equal to y square minus y plus c. This is the equation, and here v equal to into dx. So v value is minus 2x into dx into, this is the partially, and you so so suppose the y by dx equal to c by dx. This is one equation, and this value is put this equation, and v value is minus 2x equal to delta c by dx, delta c by delta x, and integrating both of them x square. So c value is x square, and put this is the equation 1, and get the value c value in the equation 1. We got y plus minus x square. This is the equation of streamline, and streamline function at 4,5. So for y 5 square minus 5 minus 4 square, 25 minus 20 equal to 4 unit. Answer is 4 unit. Understands? Next, type of motions. Types of motion. Type of motion. Number 1, linear translation. I already discussed the translation is two types, but this is normally translation and rotation, and here this is the linear translation. Linear translation. What is linear translation? When the body of fluid elements, the movement, it is defined as the movement of fluid elements, the movement of a fluid element movement of fluid element such a way that the it it move it move bodily it moves bodily from one position to another position, from one position to another position, and access and accesses of fluid element of elements, fluid elements or element, accesses of element accesses of elements are parallel in the old position and old position and new position are parallel. New position are parallel means, suppose this is a plane xy plane. Suppose this is a body. This is suppose axis a b c d. This is the old position of the a fluid element. This is the fluid element. And bodily move. Suppose and move from one position to another position. Bodily move. A dash, B dash, C dash, D dash. Suppose this is the small d, this is the D dash. Bodily move and their axes are parallel. Understand? This is the linear translation. Next one is linear deformation. Linear deformation, it is defined as the deformation of a fluid element linear direction when body moves and accesses of the elements in the deformed or undeformed and undeformed position are parallel. Understand? Suppose this is the y and x plane. Suppose linear deformation. This is suppose A, B, C, AB axis and DB. And when body moves, and the axis is that, suppose this is the A dash, B dash, C dash, D dash. The body deform, their relative position change. This is undeformed, this is the deformed position, and their axes are parallel. Understand? Next one is angular deformation. Angular deformation, angular deformation, or shear strain rate, or shear deformation. And this it is defined as average defined as the average and change in angle containing change in angle by two adjacent side. Means suppose this is the body and now suppose like that, means understand. Suppose this is the value, this value is delta theta 1 and this value is delta theta 2. This value is delta theta 1 and delta, where delta theta 1 and delta theta 1 and delta theta 2 change in change in angle between two adjacent sides of between two adjacent side of fluid side of fluid element sides of fluid element to adjacent side of. So this theta 1 is dv by dx, dv by dy, sorry, and this value is du by, this is the x direction, so dx. Understand? So angular deformation, angular or shear strain rate, this is the shear strain rate, angular deformation, and this is the angular deformation or shear strain rate or shear rate. This is the important, very important. This is, I say, average change in angle, the theta by delta theta 2 by 2. So this is the shear strain rate. So this shear strain rate equal to, I put the value half into dv by, dv means this is delta, you can write partial derivative, this is suppose partial, this is the partial derivative of dv, put the value dv into dy du by dx. This is shear strain rate. This is very important. Note it down. Number 4 is rotation. Rotation.